Hello everyone, this is Dr. Zach. So for today, we're going to take the time to review those applications of integration. And what I would like you to do is complete the 8 questions that are on today's note sheet. Once you've completed those questions, then watch the video. I will go through some of your answers. All right, so go ahead and get started. Turn off your video. So for your first question, you were thinking about velocity, acceleration, and distance. In order to figure out what the velocity needed to be to reach that 550 feet, you had to write your distance equation. Your position equation was then set equal to 550, and you could solve for the variable v naught. Now, v naught is just another constant in this problem, and you solve for v naught. Once you have v naught, you have answered your question. Make certain that you write your answer in terms of feet per second. So question number 1 was an area problem. You began by graphing the function. Recognize that x equals 2 and y equals 0 are boundaries for this problem. So you're going to integrate from 0 to 2. Find that antiderivative, then use the fundamental theorem of calculus in order to determine your area. For example number 2, you were given a velocity graph and asked to estimate how far the car travels before it comes to a stop. You stop when your velocity is 0. So I drew some rectangles and a triangle and estimated the area under these curves in order to determine this area. For question number 3, you're asked to find the average value of the function. So using your average value formula, you're going to integrate from 1 to 3. Find your antiderivative, substitute the numbers 1 and 3 in using that fundamental theorem of calculus, and then to determine where the average value is equal to 16 over 3, take your function and set it equal to your 16 over 3. You should find out that x is equal to your positive answer. So the last question on this page is asking you to evaluate an integral, but that of course is area. Bust the problem into different shapes so that you can find the exact area. To determine the average value, it's the integral from 1 to 7 multiplied by 1 over b minus a. Then you can determine the parts a and b when the graph is translated up 2 units. So if you're translated up 2 units, you're going to have a larger area, which will be 2 by 7, and that's 14. Add 14 to your answer, and you are set. For example 5, you're asked to find, let r prime of t be the rate of growth of a dog. So if you were to let r prime of t equal pounds per year and integrate pounds per year, you're going to get pounds. So when you integrate from 2 to 6, that's going to be the number of pounds that your dog has grown between the ages 2 and 6. So for example 6, you were given the velocity of the blood. And the velocity of the blood, when you integrate it, you're going to find the average rate of flow if you multiply by your 1 over b minus a. You're using 0 to 0.05 as your limits of integration. That will allow you to solve for your problem, and k will remain in the problem. Number 7, you're asked to find the displacement. Well, displacement is the antiderivative of your velocity. Using the fundamental theorem of calculus, substitute your 5 in to your antiderivative minus 1. Now, total distance is absolute value of velocity. It would be very reasonable if you chose to use your calculator to complete this problem. For your last question, you were given a graph and some information. The shaded region A is 1.5, and the integral from 0 to 6 is 3.5. So with that information, you should be able to calculate B using that fundamental theorem of calculus. You have many different intervals that you could figure out. And of course, lastly, question F, what is the average rate of change over your interval. So each piece can be found if you know your fundamental theorem of calculus. All right, so that concludes questions 1 through 8. You should now feel pretty good about the applications of integration. And what I would like you to do next is work on some follow-up. So on page 288, I have 4 questions in particular that I'm interested in. And then if you feel like you need more practice, pick and choose any questions from 1 through 56. Please do not do all of the questions. Pick and choose the ones that look like they might be challenging. That's it for today. Enjoy yourself.